So in this video lecture, we're going to review from the class before this one, adding and subtracting fractions, and kind of how to show that using the area model is usually the model we use for that. So let's talk about, before we look at how to show with a model, how do you normally add and subtract fractions? Or how would you teach it? Okay, so the rule for adding and subtracting fractions is that there must be a common denominator. And so we teach this to our students pretty early on when we talk about fractions. And we teach them how to change that denominator, how to find a common denominator. But much of the time, maybe they don't understand why, and maybe sometimes we don't understand why, and that's a problem. Okay, so we change, we make sure there's a common denominator, and then what do, right? We add or subtract the numerators, and we keep the denominator the same. Can't spell today, I guess. Denominators, there we go. So why do we even need to do something like that? Okay, so for an example, let's think about maybe two kind of common fractions. Okay, how would I add, say, 1/3 and 1/2 without doing something like this? Notice they're not equal sized pieces. Okay, so that's why I need a method like this. So this is going to be how I'm going to want you to show in picture form the fact that we're really going to change those denominators. So first, you start off with a rectangular model. Remember, we argued that that's probably the easiest way to draw fractions, the area model involving rectangles. Okay, now I didn't do perfectly. I didn't make sure the pieces were exactly the same size, but I think you get the idea. So here's 1/2 plus 1/3. And there went my pencil. Okay, and notice these aren't equal sizes, right? Also note that the cuts are in opposite directions. That's going to make the method that we're going to use here a lot easier if you make the cuts in opposite directions. In other words, do one horizontally and one vertically. Okay, so now we're going to overlap those cuts. So we're going to show what we had originally to kind of show that, hey, those pieces aren't of equal size, we can't really do that. But now let's overlap the cuts. We're not going to change the area that's shaded in. And by the way, you try to make the rectangles kind of the same size. So I'm going to start with the exact same thing as what I had. I like to use different colors for this method just so that I later on can kind of look and see, you know, which pieces came from the first set versus which pieces came from the second set. Okay. And let's put a plus sign here. So if we were going to try to plus these or add these together, right? But if we'll overlap the cuts, so in other words, the one that did have a horizontal line, let's draw two vertical lines, and then vice versa. Okay, notice what we have now. The area is still exactly the same, but now this is actually 3/6, and this is actually 2/6. And now that they're equal sized pieces, we can feel free to combine those. And so we're going to show this with a picture, right? So we took 3 from the first picture, and then we're combining that with 2 from the second picture. And then in the end, we have a picture version of why the result when we add 1/2 plus 1/3 is 5/6. Okay, so that's going to be our strategy. So let's try one on your own. And if you feel like you have this already, you know, you can always pause the video and kind of see if you can do it on your own and then compare your answer to mine at the end. So I always want you to start with what you're given. Don't gloss over that or skip over that. You have to show the picture version of what you're given. So here we have a third plus a fourth. Notice it's easier to draw the lines vertically typically, especially if you draw the rectangles like this. So the more lines I need, I tend to put that one vertically because it's really hard to squeeze pieces in here. So I've got 1/3 plus 1/4. Okay, notice clearly those pieces are not equal size, right? So this is going to change to something else. But notice I start off with the same information and then I partition it kind of after the fact. Okay, so I've got a third plus a fourth, and now I'm going to overlap my cuts. So notice now I have 4/12 plus 3/12. And if I combine that together, no surprise, I'm going to get 3 plus 4 or 7/12, right? But let's finish up the picture. So 4 that were this purple color, and then 3 more that were the red, and then that gives us a total of 7/12. Okay, so notice you could teach this method and you could have students finding common denominators when they don't even really know they're doing that yet. So this would be a great way to introduce the addition and fractions. And then later on, if you don't want to, obviously there comes a stage where you won't want to have a picture drawn for every single problem. That becomes tedious, right? But at least at first, when you're wanting them to understand why you're doing what you're doing, models and manipulatives can be really helpful. All right, so we're going to start off with 1/2 plus 3/5. So I'm going to do the 1/2 this way, probably the 5ths this way. So always start off with your original. So I have a 1/2. And I'm going to add 3/5. So I start off with a 1/2 plus 3/5. Okay, but that's a no-go because the pieces aren't of the same size. So I'm going to repeat my shape. It's important to note here that it's really important that the area being shaded isn't changing. All that's being changed is how you split or partition it up. Okay, so now same area, but this time we have 5/10 plus 6/10. So we'll draw our shape, and we know we have 5 from the first set, right? And then we need 6 in the second set, but notice we only have room for 5, right? Well, that just means your result is bigger than 1. So you need a whole other set here. You would not just draw the partial, you would draw the complete whole. Okay, so now I can do 6 of the red. And notice we could write this 2 different ways, right? We could write this as 1 1/10 because it's 1 whole plus an extra 10th. Or we could write it as 11/10. And depending on what you were teaching at the time, one or the other might have been the better form to choose. So as long as it's reduced, and both of these are reduced, it's just this one's improper. I don't really care which way that you do. In other words, I don't want you to leave an answer. If you happen to do one and the answer is 4/8, I don't want you to leave that as 4/8. I actually want you to change that. All right, so let's talk about subtraction. Subtraction works much in the same way. It's just instead of adding pieces together, we're going to be taking pieces away. But the general pictures are going to look very, very close. So we're going to start with what we were given, right? 1/2 minus 1/3. So I've got 1/2 minus 1/3. For the same reason that I couldn't add these pieces, because they're not of equal size, I can't subtract them either. Okay, so this is going to change to and again we start off with the pictures being the same as originally drawn. But then one more time we're going to overlap the pieces just like we did with the addition model. So now notice we have 3/6 minus 2/6. So here is where we're actually going to, a piece at a time, cancel things out. In other words, this piece cancels with this piece. Okay, this piece subtracts this piece away. So in the end, you're only left with this one little piece. And I'm usually careful to make it the same piece that was left over here. And so in the end, your answer is 1/6. So notice, just like the addition model, I want the original, I want what it changed to, and I want a picture form and also the fractional form of your answer. All right, so let's do one more, and then I think we'll have covered addition and subtraction enough. So I wanted to look at one where maybe we had a fraction that was larger than 1. So for that, make sure when you're talking about different wholes that you show them separately. So I would probably show 1 1/3 maybe like this. Now I'm going to go ahead and split up both pieces into thirds. And then this one, of course, you always go the opposite direction. So I've got a whole 1, right, and then an additional third, and I'm going to subtract off 3/3. So when you label this, I like to do this right here just to let myself know that this whole set of 2 is the 1 1/3, and then I'm going to subtract 3/4. And if you were teaching this to younger students, you could already kind of give them a guide if you wanted. If you found that them actually drawing the rectangles was becoming kind of tedious, you could give them kind of prefab, already done worksheets where some of the shapes were already there for them. Especially if you were just wanting to quickly review it, or if maybe you had younger students where the drawing of it would actually be a little bit of a challenge. So we're going to cross section everything. So just like we did before, I'm probably not going to leave this as a whole number this time. I'm probably going to say, okay, I have 12 here, 13, 14, 15, 16, but make sure you understand that it's actually 16/12. Okay, it's not 16/24, because remember the denominator represents how many pieces make one whole. And one whole is made, let me move that up, one whole is made with 12 units. And then, of course, we're subtracting 9/12. So you would cancel all these out, 9 of them, and you would cancel 9 of these, right? So those 4 first, and then really just any of 5 of these. The trick here, though, is, again, try to make the pieces that were remaining the same pieces that you color in the end. In other words, it was these 7 pieces that were left. So in the end, my answer is 7/12. So I hope you can kind of see what I'm looking for with addition and subtraction with these area models. Note in all of these cases that we don't change the area, we just split it up differently. We don't change the amount of pizza we have, for instance, we just split it up into a different number of pieces. And that's important for us to know and important for our students to understand too.